Welcome to Low Stress Math with Mrs. Bono. This video is a review of the laws of exponents. Vocabulary first. An exponent is a number that tells you how many times to use the base as a factor. For example, if you have 3 with a little 4, the 3 is the base, and the 4 is the exponent. And you would read that 3 to the 4th power. It means that you would use the 3 as a factor 4 times. So 3 to the 4th power is equal to 3 times 3 times 3 times 3. You could multiply that out and you'd get 81. So 3 to the 4th power is 81. Now, you can multiply numbers with exponents, but the numbers have to have the same base. So, if you have 3 to the 4th power times 3 to the 2nd power, well, that would be equal to 3 times 3 times 3 times 3, 3 to the 4th power, times 3 times 3. And that would be equal to 3 to the 6th power, because now there's 3 being used as a factor 6 times. There's a shortcut for this that's called the power rule of exponents. That's called the product rule of exponents. What does that mean? The product rule. So if you're multiplying two numbers with exponents and the bases are the same, you can keep the base and add the exponents. So what does that really look like? I have 3 to the 4th power times 3 to the 2nd power. The base is 3, so I'm going to keep that base 3, and I'm going to add the exponents 4 plus 2. And I still get 3 to the 6th power without having to write out all those 3's. Now, sometimes you're going to have variables. So if I replace the base 3 with a variable like x, I'd have x to the 4th power times x to the 2nd power, and that would equal x to the 6th power. It's the same thing, only instead of 3 as a base, now I have x as my base. Sometimes you're going to have numbers and variables together. The key is to group the like terms. So you're going to multiply the numbers or the coefficients, and you're going to keep the base and add the exponent, even if there's more than one base. So for example, if I have something really hard, like 5x squared y to the 3rd times 6x y to the 4th, I'm going to multiply the numbers, the 5 times the 6. I'm going to keep the base x, and I'm going to add the exponents. 2 plus, there's no exponent on that x, but there's only one x there. So because there's only one x, I can use the exponent 1. I could put a 1 here and say 2 plus 1. And I also am going to keep the y and add the exponents for the y also. So y has 3 and y has 4. I do 3 plus 4. Now multiply 5 times 6 and I get 30. Add 2 plus 1 and I get x to the third. And add 3 plus 4 and I get y to the 7th. So when I'm all done, I get 30 x to the third, y to the 7th. Now you can divide also. So if I'm dividing, I'm going to be doing the quotient rule. So let me change pages here, get back up to the top, and this is going to be the quotient rule. So the quotient rule of exponents is basically the same. So you're going to have numbers and bases and exponents. So let's just start with a number 3 and an exponent 5 divided by the same base 3 and an exponent 2. Now, you're looking at that, you're thinking it's a fraction. It is. Fractions are just division. Don't be afraid of division. It's easy. So that would mean I have 3 to the 5th power. That's 3 used as a base, and I'm going to take it 5 times. So 3 times 3 times 3 times 3 times 3. And I'm going to divide that by 3 squared, or 3 times 3. Wait a second. 3 divided by 3 is just 1. 3 divided by 3 is just 1. What I have left, 3 times 3 times 3, is going to be 3 to the 3rd power. Now I can do the same thing with variables. If I had x to the 5th power divided by x squared, it would be the same. X times x times x times x divided by x times x. And I could just divide x divided by x is 1. X divided by x is 1. Oh, I forgot one of my x's on top. Times x. And I would get x to the 3rd power. Now the quotient rule says that I can keep the base and just subtract the exponents. So I'm going to keep the base and subtract the exponents. So now I still have that fraction. I'm going to take the top minus the bottom. So I have 3 to the 5th divided by 3 squared. I'm going to keep the base 3, but now I'm just going to subtract the exponents. 5 minus 2, and I get 3 to the 3rd power. So the quotient rule also applies when I have a bunch of variables and numbers together. So if I have an example like 12 x to the 5th, y to the 7th, all divided by 2, x squared, y to the 3rd, that's going to be equal, well, first I'm going to divide the numbers. I'm going to do 12 divided by 2. Then I'm going to keep the base x and subtract the exponents, 5 minus 2. And I'm going to keep the base y, and I'm going to subtract the exponents, 7 minus 3. And when I'm done with that, I'm going to get 4 x to the 3rd, y to the 4th. Right. Now, if your base has more than one exponent, That is a power to a power. And it usually would look like this. So let's do, back up to the top, the power rule. Now that's going to be a number that has two exponents, like 3 to the 4th power squared. What does that mean? That means parentheses 3 to the 4th power times 3 to the 4th power. See, the square says to use 3 to the 4th power as a base and write it down twice. But now it's multiplication, and I can just use that rule. And I would do 3, 4 plus 4. And that would give me 3 to the 8th power. Now I could do something similar if I have variables. Let's say I have x squared, and that's my new base to the 4th power. Well, that would be x squared times x squared times x squared times x squared. What's that? That is x to the 2 plus 2 plus 2. I'm running out of space, plus 2. And that would equal x to the 8th power. Oh, that's a lot of work. There's a shortcut. So the power rule of exponent says keep the base. It always says keep the base. And multiply the exponents. So for the top problem, that 3 to the 4th power to the 2nd power, that's a lot. There we go. 3 to the 4th power, that base to the 2nd power would be 3. You 4 times 2, and you get 3 to the 8th power. And the x, which is squared to the 4th power, would be x to the 2 times 4, or x to the 8th power. I like the power rule. Kind of makes it a little bit easier. So now, if I have a power rule and I have numbers and variables together, I am going to distribute the outer exponent to everything inside the parentheses. So if I have 3x squared y to the 5th power, and that whole thing is to the 4th power, I would distribute it. I would do 4 goes to the 3, and that 4 is going to go to the 2, the 4 is going to go to the 5, and that would be 3, and it would have the 4th power, and then my x squared, I would multiply that 2 also times the 4, and I'd have the y to the 5th power also times that outer exponent 4. Now, 3 to the 4th power is 81. X, 2 times 4, 8th power, and y, 5 times 4, the 20th power. So my whole thing would be 81, x to the 8th power, y to the 20th power. The next one is negative exponents. So let's take a look at negative exponents. What does that look like? It's something like 3 to the negative 3rd power. And when you have a negative exponent, it's a reciprocal. So you would have 3 to the negative 1st power, negative 3rd power. Oh my God, I don't have my whiteout. Okay, there we go. And it would be over 1. So then, To get rid of the negative exponent, you reciprocate it. You flip it over. And now I have 3, and it's positive to the third power on the bottom. And it's a 1 on top. Now, when you have an exponent like 3, you could just multiply it out. 3 times 3 times 3, and get 1 over 27. The same thing is going to apply if you have a variable. So for instance, I have x to the negative second power. That's going to be equal to x to the negative second power, and it's still over 1. And I'm going to reciprocate. I'm going to flip that over and get 1 over x squared. So when you have a negative exponent, you make it a fraction, and it's positive on the bottom. Once you flip it over, that exponent becomes positive. So let's say you have numbers and negative exponents and variables all together. Only the part with the negative exponent is going to go in the denominator. So if I have 3x to the negative second power, only the x has the negative exponent. 3 doesn't have an exponent. 3 is just 3. So this is going to be equal to 3, and the part with the negative exponent goes in the denominator, x squared, and it becomes positive. Now, there's also 0 exponents. So let's just finish up negative exponents first. Here we go. So negative exponents become positive when you flip them over and put them in the denominator. What if they're in the denominator to start? We'll do that one too. So, negative exponents So now what if the negative exponent is already in the denominator? If you have, say, 5y cubed over x to the negative 3, the x to the negative 3 is still going to flip over. You could separate it and have 5y to the third times 1 over x to the negative 3. Only this part would flip. And cat, hey, get off of here. You'd have 5y to the third, and now that x to the negative third becomes x to the positive third on the top. Now the last thing we're going to talk about is the 0 exponent. Let me flip the paper one more page, and we'll do 0 exponents. What's a 0 exponent? Here we go. The 0 exponent. Says any number to the 0 power is 1. Now, why is that? Well, let's take a look at a problem, an example for that. Let's do 2 to the 4th power divided by 2 to the 4th power. Now, if I were to apply the quotient rule, I would do 2, and it would be 4 minus 4, and I would get 2 to the 0 power. Cool. But if I did an expanded notation, if I said 2 to the 4th power, I'm going to use that as a base 4 times, 2 times 2 times 2 times 2, divided by 2 to the 4th power. Now I'm going to use that as a base 4 times, 2 times 2 times 2 times 2, 2 divided by 2 is 1. 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 So that's really 1 times 1 times 1 times 1. That whole thing is equal to 1. But Bono, you said that 2 to the 0 power. There you go. It's the same thing, the quotient rule. If I subtract them, I get 2 to the 0 power. If I expand it, I still get 1. So that means 2 to the 0 power is equal to 1. Now you could do the same thing with variables. And you could have x to the 0 power equals 1. Or you could have pieces of it. So sometimes you're going to have numbers and variables together, and only the part with the 0 exponent would become 1. So if I have 3x to the 0 power y squared, well, nothing happens to the 3. X to the 0 power becomes 1, and nothing happens to the y squared. Well, 3 times 1 is just 3, y squared. So that x became a 1, but it was really 3 times 1. So that's why it's just 3. Okay, I hope I clarified the laws of exponents for you. Please finish the assigned paper by tomorrow. Email me with your questions. You have to be specific with your questions. Please don't tell me you don't understand any of it. Go back, rewatch the video, maybe even write the notes down for yourself. And I hope you have a great day. Keep yourself happy and healthy. And I will talk to you tomorrow. Bye.